For loop. In the previous lecture, we discussed the introduction of loops and their types, and we also discussed their syntax. In this lecture, we will talk about for loop. So, for loop is probably the most common and the one we'll look at first. The for loop is used when we know how many times we need to execute a block of code. It includes setup to initialize variables, check loop expression, and update code, which often includes incrementing an iteration variable. For statement is also called for loop because it loops something over and over again until the condition is met. When I say repeatedly loops, I mean it's processing a certain amount of code and a code block. In other words, the given number of times or until a particular condition is satisfied. Now start with a simpler example using for loop. So we write a program to print numbers from 1 to 5 using a for loop. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named for loop. Then create a main method inside this for loop class by writing shortcut psvm. In the main method we write for open parenthesis int I equals 1 semicolon, I less than equals to 5 semicolon, I plus plus close parenthesis curly braces. Then inside the loop body write system.out.println parenthesis I. So here loop starts with initializing a variable I to 1, that is int I equals 1. Then loop condition is checked. Since I is less than or equal to 5, the condition I less than or equal to 5 is true and the loop body is executed. Then increment the value 1 by using I++. Then loop body consists of a single statement that prints the value of I to the console using system.out.println parenthesis I. Now we run it. Here is the output after a successful run. That is 1 to 5. In this case, I is 1, so the first output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then loop condition is checked again. Since I is less than or equal to 5, the condition I lesser than equals 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. Then loop condition is checked again. Since I is less than or equal to 5, the condition I lesser than equals 5 is true and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Again, loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 4. Then again, loop condition is checked. Since I is less than or equal to 5, the condition I lesser than equals 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 4, so the output is 4. Then again, loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 5. Loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equals to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 5, so the output is 5. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 6. Loop condition is checked again. Since I is now greater than 5, the condition I lesser than equals 5 is false and the loop exits. Now we see another example using for loop. So we write a program that iterates from 1 to 10 and prints each number to the console except for 5. If the loop encounters the number 8, it should immediately exit. Now let's start creating this program. Here we create another class file named for loop1. Then create a main method inside this for loop 1 class by writing shortcut PSVM. In the main method we write for open parenthesis int I equals 1 semicolon I lesser than equals 10 semicolon I plus plus close parenthesis curly braces. So here loop starts with initializing a variable I to 1, that is int I equals 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true and the loop body is executed. Then increment the value by 1 using I++. Then inside the loop body write if parenthesis I equals 5 curly braces continue semicolon. Here if statement is checked to see if the condition is true. In this case the condition is whether I is equal to 5. If the condition is true, the continue statement is executed, which immediately skips the rest of the current iteration of the loop and jumps to the next iteration. In other words, it bypasses any statements in the loop body that come after the continue statement. If the condition is false, the continue statement is not executed, and the program proceeds to the next statement after the if statement. So, continue statement allows the program to skip over certain iterations of a loop based on a specific condition. Then write else if parenthesis I equals 8 curly braces break semicolon. The else if statement is checked to see if the condition is true. In this case, the condition is whether I is equal to 8. If the condition is true, the break statement is executed, which immediately exits the loop, even if the loop condition has not been met yet. This means that the program will skip over any remaining iterations of the loop and continue with the next statement after the loop. If the condition is false, the else if statement is not executed. The program proceeds to the next statement after the loop, or to the next statement in the loop body if any. We already discussed break statement in switch statement lectures. Then outside of these conditions, we write system.out.println parenthesis I semicolon. Now we run it. Here is the output after a successful run. So here you can see that 5, 9, and 10 numbers are not printed, because in this example, when the loop runs first time, the variable I is initialized with 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console using the print statement. In this case, I is 1, so the output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. The loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Steps 4, 6, and 7 are repeated for each subsequent iteration of the loop, with the output being 4, 6, 7. But when I is equal to 5, the if statement is executed, and the continue statement is executed, which skip over remaining iterations of the loop and continue with the next statement after the loop. Similarly, when I is equal to 8, the else if statement is executed, and the break statement is executed, which immediately exits the loop. Then the loop is finished, and therefore the final output shows 1, 2, 3, 4, 6, and 7. Now we'll look at a slightly more complicated example that makes use of the for loop. So we write a program to check whether the given number is prime or not. Now first we discuss what prime number is and how to find them. So prime numbers are a special type of whole numbers that have exactly two factors, 1 in themselves. This means that they cannot be divided evenly by any other positive integer except for 1 and the number itself. For example, 2 is a prime number because its only factors are 1 and 2. Similarly, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31 are prime numbers because they only have two factors. As you can see there, it lists the prime numbers of 1000. For instance, the number 7 cannot be divided by any number other than 1. That will produce a whole number, so it's a prime number. 7 divided by 1 is 7, and 7 divided by 7 is 1, which are both whole numbers. But any other number will result in a decimal number. Whereas 9 can be divided by 3, which equals a whole number, and therefore it's not a prime number. The number 1 is not considered as a prime number, but the number 2 is. However, any other number divisible by 2 is not a prime number. That's a super simplified explanation. For those of you who hate math, don't worry, I'm not going to ask you to create the prime number method on your own. Prime numbers are used in computer science to generate random numbers, and in various algorithms for optimization and search. Moreover, prime numbers are also used in various areas of mathematics, such as algebra, geometry, and calculus. For instance, prime numbers appear in the study of polynomial equations, elliptic curves, and number fields. I think now you better understood what a prime number is. Now we discuss how to find them. So there are many ways to find whether a given number is prime or not. Divide the given number by 2. Take the first half of given number and start dividing it from 2 to last half number. If any one number divides the given number completely, then it's not prime number, otherwise it's prime number. Now let's create this program. First we create a class file named findPrimeNumbers, and then inside it create main method using shortcut PSVM. We're going to create a prime method before we do anything else. First, let's create the method using public static boolean is prime, opening parentheses, int whole number, closing parentheses, curly braces. Return true semicolon. So it will be returning a boolean from this method. True if the number passed, which is the parameter, is a prime number, and false if it isn't. So the parameter name is whole number, and I've used this as prime as the method name. Because this method isn't really operable, we'll just return true. Let's add some simple test cases to our main method. We'll test the number 0, and here's a decent opportunity to use the ternary operator. If the number is prime, the text will say a prime number, and if the number is not prime, the text will say not a prime number. I'm going to the main method. Now write system.out.println opening parentheses double quotes. 0 is plus opening parentheses is prime opening parentheses 0. Closing parentheses question mark double quotes colon. Double quotes not closing parentheses plus double quotes. A prime number closing parentheses semicolon. So you can see we're calling the method here, asking at the number 0 in this line. And this is making the call to the isPrime method from the first operand of the ternary operator, which uses the question mark and colon. We're concatenating an empty string, but if it's false, we'll slip in the word, not in the text, because prime method always returns true. When this code will run, it will indicate that all numbers are prime numbers. First, we'll check if the number is less than or equal to 2 with if-then statement. If it's less than or equal to 2, we want to return false. If the number is negative, 0, or 1, because these are not prime numbers. If the number is 2, however, we want to return true because 2 is a prime number. So we can do this by returning the value that will be returned from the Boolean expression. Whole number equals 2 using the double equals sign, here the equality operator. Now we write if opening parentheses, whole number less than or equal to 2, closing parentheses, opening curly brace, return opening parentheses, whole number equals to 2, closing parentheses, semicolon. So now let's see where we're at and run that with our test case. Here you can see the output that 0 is not a prime number. So you remember to set up a for loop. We need a starting point, a condition to stop it, and a way to increment the variable that we're checking. So let's have this for loop. For open parentheses, int divisor equals 2 semicolon, divisor less than whole number semicolon, divisor plus plus closing parentheses curly braces. We create a variable called divisor. This is the number we'll be dividing the whole number by. We'll keep flipping if the divisor is less than whole number. If we use less than or equal there, instead of less than, then would have the condition. That whole number would be divided by itself at the end, and it would then say that the number was not prime, which would be wrong. So make sure this is just the less than symbol by itself, and then we'll increment by 1 each time. So the postfix operator will do the job for that. Now thinking about the number 8, that's the whole number. For example, we'll be looping from 2 to 7, incrementing by 1 each time. And what do we want to check each time? All we want to know if the whole number is evenly divisible by that loop variable, which we're calling divisor. What operator can we do this with? The remainder operator is modulus operator, whatever you like to call it. Let's add that code. If opening parentheses, whole number modulus divisor equals 0, closing parentheses curly braces, return false semicolon. Here we have an if statement that checks if the whole number is divisible by the loop parameter, which we're calling divisor. If our whole number can evenly be divisible by any number other than itself. So that is any number between 2 and 1 less than its value. This means the whole number can't be a prime number. In other words, we've had a number that evenly divides into whole number, which means whole number isn't prime. We start with 2 because everything is divisible by 1. So starting with 1 would give us false positives. But notice that every even number will return a false on the first iteration of the loop. So that's pretty efficient. But it also said that we're just putting a return in that if code block. This will exit the loop at that moment when the condition is true, breaking out of the loop and exiting the entire method returning false. Now to test, we first add more cases. For this, we go into the main method and write system.out.println opening parentheses double quotes. 1 is plus opening parentheses is prime opening parentheses 1. Closing parentheses question mark double quotes colon. Double quotes not closing parentheses plus double quotes. The prime number closing parentheses semicolon. Now copy and paste this line many times and now change their values that are 2, 3, 8, 17 and 21. Now run it. Here you see the output, that is 0, 1, 8, and 21 are not prime numbers, and 2, 3, and 17 are prime numbers. There are other ways we could program this, but This is a pretty easy way to get your answer and get out of the loop and subsequently the method. When you're using loops, it's a good idea to see if there are any ways to cut down on iterations, especially if the code block that's being executed is complex or creating a lot of variables. One minor thing we could do is change the code to iterate over fewer values. We could use the halfway mark for a number as the maximum value. Let's make those two minor changes, changing less than 2, less than or equal to the whole number, to whole number divided by 2. So think about it for a minute, why this is more efficient. And what should still work. Anything that is divisible by the smallest number 2 will also be divisible by that whole number divided by 2. So checking numbers greater than half the whole number is really just wasted effort. Now run it. Now you can see that gives us the same results. I hope you learned something useful in this lecture as well. And I'll see you in the next one.